Three questions on worksheet number 4 for homework, questions 4 to 6. We're going to do questions 5 and 6 here, starting with number 5. Bomb sitting on rest at a table explodes into 4 pieces. First piece travels to the south. Second piece travels to the west. Third piece travels west of north. What's the velocity of the fourth piece? I know a couple of people a couple of days ago asked me about this one. About how do we know where the fourth piece goes? Well, we don't exactly. That's why we're doing the question, because we don't know exactly where it goes. But we can make an educated guess. Let's draw a situational diagram. This is where the explosion point is. We have one piece going, what do we say, south? Let's call that piece number 1. Its mass, oh, it's equal masses. That's good. We know what's going to happen here, right? Yeah, the mass is going to end up canceling out because it's going to be the same mass in every term. I love it when that happens. This is 55 meters per second. We have another piece going to the west. That would be piece number 2 right here to the west. Its velocity is 80 meters per second. Then we have another one going west of north. That's going to be piece number 3 up here. Remember, west of north, it's west and it's north, like I've just drawn this. Where am I going to label my angle, right here or right here? Position 1 or position 2? Position 2, yeah. This is measured from the north. It's touching the north, right? So it's of north, west from the north. If I do it down here, then it would be touching the west, and it would be of the west, from the west. And that's not what we want here. We want from the north. So west of north. Where do you think the fourth piece is going to go? Again, we don't know exactly. We do know something about it, though. What was the initial momentum of this bomb before it exploded? That's an easy question. What's the momentum of this bomb before it exploded? 0, right? 0. No trick. It was 0. What's the momentum of this bomb after it exploded? 0, right? Okay. Well, if you have 0 momentum before and 0, more importantly, 0 momentum after, but yet something goes to the west with, let's say, piece 3 and piece 2 go to the west with a combined momentum of, let's say, 10 to the west, negative 10. Well, then piece number 4 has to have positive 10, right? Because the total momentum in the east-west direction has to be 0. So we know that piece number 4 is going to go to the east, somewhere to the east, right? Now, north and east or south and east? That's a tougher one, because we don't know how much upward momentum this one has, how much downward momentum this one has. Okay, we know it goes to the right, piece number 4, but does it go down and to the right or up and to the right? It's pretty hard to tell down or up. It really is. If we had just piece number 1 and not number 3, we'd know for sure it was going up and to the right. But because we have a down and an up already between piece 1 and piece 3, 4 could be going up or down. Don't know. Here's, listen, if you do enough of these questions, you tend to kind of get a gut feeling as to which way it's going to go. But in the end, if I'm wrong on that, it's not a big deal. Like, this is just to help us visualize what's going on. So it's not critical that I get this part of the diagram correct. All right. What do you see here? What jumps out at you as to something that we should do next? Yeah? We don't like funny angles, right? I don't like funny angles. So we get rid of it. We take it off over here, and we get rid of it. This is, what was that? 40 meters per second? So we got 40 meters per second. Here's an X component. Here's a Y component, and we got an angle of 30 degrees here. We can find the X component by using, careful here. Which trig function? Amelia? No. The X component is going to be found by using sine, because it's the opposite side of the triangle this time. Right? Most times you do one of these, the adjacent side is X. Right? But that's because most times our angle is measured from the X-axis. So here we're going to say sine 30 degrees is equal to opposite over hypotenuse. So the X component, or the opposite, is 20. And the Y component is going to be found by using cosine. And the Y component ends up being equal to 34.641. And then I just, do what I do, right? Box it off because this is what I do. I like structure. I like it being the same every time. I like being comfortable when I get a test question in how to do something because I'm used to doing it the same way every time. We can, if we want to, replace this, right? We could call this 34.641, and we could call this 20. And if we wanted to, we could erase this whole thing, right here, right? Because we're never going to use it again, right? Once we resolve it into its vector components, we're never going to use that number again, ever. If you don't want to erase it, that's fine, but just ignore it, at least. Now what? Now what? You guys all know this. What comes next? Yeah, Colton? X and Y components, right? So we do the X component by saying, what, PI is equal to PF. What's the initial momentum, Colton, of this bomb sitting at rest before it explodes? Good. Equals M1 V1F plus M2 V2F plus M3 V3F. This is the first time we've had 4 of them. But in the end, that doesn't make it harder, really, right? It just makes it more work. You could have 50 pieces flying off, and we do it the same way. We just have a lot more work to do. That's all. Masses cancel because it's the same mass. And everyone, that makes the math easier. V1F. Now remember, we're dealing with X component here, right? So we're paying attention to what happens only on the X-axis. Only on the X-axis here. Jackson, what's the X component of the velocity of object number 1? Yes, because it's all on the Y-axis, right? Some of you aren't even going to put that in there at all, right? You recognize that right away, but I'm going to put it in. What's V2F? Richard, what's V2F there? Remember, dealing with the X component here. 32? Nope, number 2. Object number 2 here.
Yeah, I can't see what it says. 80?
Yeah.
All right.
We're going to make it negative 80, though, because it's to the left, right? What's V3F? Evan, what's V3F there? Object number 3, right here, X component.
Component?
Yep. Yeah, we're going to make it negative, though,
Oh.
because it's to the left, right? Because it's to the left. Plus V4F. Oh, man, this math is easy. This is negative 100. Take it over to the other side. V4F is equal to 100. I said it was going to the right and up. I still don't know anything about up or down, but I know that I was right, correct, that is, about it going to the right. How do I know that? Because it's positive, because the X component of that V4F is positive 100. I know it's going to the right. Now, up or down, I'll find out now when I do the Y component. Now, I'm going to say, I'm running out of space here, so I'm going to skip a step just to save space here. I'm going to say 0 initial momentum equals, what's the Y component of this 55? Jen, what's the Y component of that 55? Yes, we're going to make it negative 55 because it's downward. What's the Y component of the 80? Object number 2? Sam? 0, good. What's the Y component of the 40 meters per second that's dead to us? Matt, what's the Y component of that 40? 34.641, and it's positive because it's up, right? Plus V4F. So negative 55 plus 34, take it to the other side. It gives us 20.359. You guys good with that? Yeah? Cool. What do I do with this now? Yeah, draw a vector diagram. What do we got? 100 to the right. 20 is positive, which means it's up, right? Did we guess right? Sorry, did we guess correct? when we said it was to the right and up? Yeah, Kui? Yeah, we did. We know that because the y component is positive 20. Right? Okay, let's find that. How do we find that? Oh man, this is easy. This is like what, grade 7 or something like that? Like finding the hypotenuse there? It's the Pythagorean theorem, right? We do a thing there. It works out to be 102 meters per second. This isn't grade 7, but you can find this. Grade 9, maybe grade 10. The inverse 10 of opposite over adjacent. Oh, that's about, I'll do a lightning fast calculation in my head. 11.5 degrees north of east. Or I'll cheat and look at my sheet. 11.5 degrees north of east. Good. What else could we say? What, 78.5 degrees east of north? Okay, if you drew it the way that I did, you're going to get that, right? But if you had drawn it like this, and that would be okay, you would have gotten 78.5 degrees. Exactly the same thing, right? Remember we said 2 meters from the front of the room, 6 meters from the back of the room. It means exactly the same thing. Sounds different. Means exactly the same thing. Just 2 different reference points. Same deal here. North of east, 11.5 degrees. East of north, 78.5 degrees. Good. How many people got that? Okay. Not bad. But hopefully by the end of this we have a little bit more success than that. Ooh, 16 is tricky. This bomb is moving at 10 meters per second to the west. Explodes into 3 pieces. Moving to the west, explodes into 3 pieces. 100 kilograms moves west, 90 meters per second. Second moves north of east. Third moves 55. What's the velocity of the third piece? I don't know. I think it's probably easiest just to draw it like we have been drawing it. And don't worry about showing the initial movement. Just show the explosion itself and just say, I don't know, maybe the initial velocity is 10 meters, oops, except it's going the other way. 10 meters per second to the west, just to remind us of that. I think if we try to draw the diagram moving, I think it's just going to get too cumbersome for us. So here's my explosion. We have 100 kilograms moving to the west at 90. Man, I wish these were the same masses. We got another one going to the north of east. This would be north of east, wouldn't it? Right, measured from the east, of the east, north of east. 55 kilograms, 55 meters per second. What's the velocity of the third piece? Where do you think it's going to go? Down. We know it's going to go down for sure. To the right or left, we're not really positive about right or left. Depends upon how big this is and how big this is and related to this. But we know it's going down. We're going to guess this. I think that's probably right. If I'm wrong, it's no big deal. What is the mass of that third piece, by the way? 45 kilograms. 200 minus what? Minus 100 minus 55. First thing? Man, I usually just say I don't like funny angles, but if you want to go that far, Parker, I guess. Parker hates funny angles. So let's take it off to the side and get rid of it. This is X. This is Y. And the angle is 30 degrees. Amelia, which trig function do we use for X this time? Oh, you know this. Oh, we'll put some thought into it then. I want you to. Good. It is cos because it's the adjacent side of the triangle, right? Cosine 30 degrees is equal to X over 55. X ends up being, what is that? 47.6314. And the y component, that's sine, so that works out to be, what, 27.5 meters per second. Good. Box it off, because that's what we do. There's no good reason for that. Just structure, right? Okay, we can replace this. And I do want to. So I will replace that with a 47 and 27.5. And I'm going to erase that vector 2, this guy right here, because I just want to remind myself that it doesn't matter anymore. Once I resolved it into x and y, it's dead. Okay? You know what comes next, right? Kellen, what comes next? Yep. PI equals PF. Ooh, what do I do for PI here? Hunter, what do I do for PI here on this guy? Moving to the west, exploding into 3 pieces. Zero initial momentum? Yeah, it's for the initial momentum. So this diagram shows the final. Yeah, I mean, that's the initial velocity, but be careful, that's not the initial momentum. But the whole thing has a velocity of 10, right? So what I'm going to do, Hunter, is say m total times vi, because it's one object before the explosion takes place, right? Wait a minute. Equals, and then there's 3 objects afterwards, m1 v1f plus m2 v2f plus m3 v3f. Does that make sense? Yeah, the total mass is 200 times vi is negative 90. M1 is, no, that's not right. That shouldn't be negative 90. That should be what? Negative 10. Good. I combined the initial mass with the final velocity, right? Equals what? M1 is 100 times negative 90 this time, plus M2, which is 55, times, what's V2F for the x component here? What's V2F for the x component here? Who's, Ernesto, what's V2F? Object number 2, final x component. For the x component here. Yep, good. The 55 is gone now, right? So we replaced it with a 47 and a 27. This one happens to be 47. And it's positive because it's to the right. Plus 45 times V3F. Man, kind of ugly there, but get this number. Get this number. Take this number over to this side by adding or subtracting whatever needs to be done. And then divide by 45 and we get V3F. You guys okay with the rearranging there? Anybody need me to show that, how I rearrange that? V3F is 97.3394. Okay. Oh, I like the y component. Yeah, I like the y component. How come? What makes the y component easier? What makes the y component easier here? Amy, what makes the y component easier? What am I going to sub into here that's easier than subbing into here? Sorry? Yes, there's 2 zeros, right? The first one is the initial momentum. How is the initial momentum 0? Didn't we say? Yes, correct. It's only going on the x-axis. So remember, when we're dealing with x, we're sort of dealing with y. We ignore everything x, right? So it is 0. Equals the second one, like afterwards, is 0 as well, right? Object number 1 afterwards. Object number 2, 55 kilograms. Tyra, what's the y component of the final velocity of object 2? positive 27.5 because it's upwards, or north, whatever, plus 45 times V3F. Now, this one's easier, way easier. V3F is negative 33.6111. Now it's just easy, right, Richard? Easy now, right? Yeah, easy now. What do I do now? If you're ever afraid of me, like, calling on you, and you're like, oh, I know what to do now, just volunteer now, and then maybe I'll be less likely to call on you on a hard one. You're not afraid of me calling on you, Parker? Seriously? Parker, what is it? What do I do?
Vector diagram.
Yeah. Yep. Yeah, that's right. So we got 97.3394 and 33.611. I think it was Amelia, wasn't it you that had kind of made an educated guess it was down and to the right? Yeah. Was she right? Was she correct about it? Yeah. Yeah, it's down and to the right. We know that because the x component is positive, the y component is negative. So V is, that's Pythagorean theorem, grade 7, whatever it is. 103 meters per second, you can do that. And theta, this is a little harder. Opposite over adjacent. Theta is 19.0 degrees. And how would we express that? Where are we measuring it from? Come on, where are we measuring this from? Are we measuring it from the south axis or the east axis? Chloe? Okay, it's measured from the east, it's of east, right? Where are we going from the east? North of east or south of east? We're going south of east, good. So that's 19.0 degrees south of east. We got a red curling rock going north, colliding off-center with a blue curling rock that's at rest. The red curling rock heads off at 3 west of north. What's the velocity of the blue curling rock immediately after the collision? Okay. So let's make the red curling rock number 1. It's going north here at 4.5 meters per second. I'm not even going to write down the mass. How come? Why am I not going to write down the mass? Yes, good. Thank you. Same mass, cancel them out, so doesn't even matter what it is. I got a blue curling rock that's at rest here. The red curling rock goes off after the collision west of north. Where do you think the blue curling rock is going to go? Listen, if I hit this blue one straight on, it's going to go straight up, right? If I hit it straight on, curling rock number 2 is going to go straight up, right? But if I hit it off center, they go opposite ways. Could go over there somewhere, right? You don't have to do this, but I'm going to put a little X there to indicate that that's where it kind of breaks apart. Funny angle over here. This isn't any different, right? Except it's not an explosion, but it's not any different, really. Here's my, what was this? 3 meters per second up here, right? 3.0 meters per second at an angle of 30 degrees. This is X. This is Y. Let's find X. Amelia, which trig function do I use for the X component there? Yeah, because it's the opposite side, right? Sine 30 degrees is equal to X over 3. And then the y component would be cosine, which gives me box it off because that's what we do. Let's replace this. Get rid of that ugly 3. With a 2.59808 and 1.5. Like, you see where I'm going with this, right? Like, you see how these questions are really all the same, pretty much, right? Like, even though this is not an explosion like the last question, it's really the same thing. Let's say, I like the x component here because the initial momentum is 0. M1 V1I, M1 V1F plus M2 V2F, but coaling rocks have the same mass, so they cancel, right? They better have the same mass. Otherwise, it's not a very fair game. V1F. What's that? X component V1F. V1F. Yeah, we're going to make it negative, actually, right? Because it's left. V2F. Oh, that's an easy math. It's crazy easy math. V2F is positive 1.5. To be honest, that's not a huge surprise. Like, we could have probably predicted that one number before we even started this because these rocks have equal mass, right? And there's no initial x momentum to it at all. So if one of them with a certain mass goes left with a certain momentum, then the other one has to go right with the same momentum, right? So it's going to be the same speed because they're equal mass. The y component, well, that won't be the case, though, because we have an initial y momentum there. We're going to say here, Parker, was your hand up there?
No.
Okay. We're going to say for this M1 V1I plus 0, because the second object is at rest, M1 V1F plus M2 V2F. V1I is 4.5. V1F is 2.59808. Take the 2.5 over by subtracting, we get and now, man, this is the easy part now. This is the part where Physics 20 students could solve the rest of this. Just say 1.5, 1.90192. Solve for V using the Pythagorean theorem, and solve for theta. That's 2.4? No, wait. I don't know, I got two different things here. Is it 2.4? I have 2.4 and I have 4. I think it has to be 2.4. And theta is the inverse tan of 1.9 over 1.5. 52. And that would be north of east, measured from the east, north of east.